Hello everyone, today I'll be sharing with you a physics experiment where I explore how friction affects the game of basketball. In this video, I'm going to explore how friction is required in movement, passing, and scoring in basketball. To demonstrate the importance of friction in basketball with explosive movements, I decided to do shuttle runs on both a wet and dry concrete court. As you can see, on the wet court, whenever I'm going to make a quick change in direction, I slide for a few centimeters instead of stopping immediately. However, when running on the dry court, I'm able to run at full speed and stop quickly to change directions. This is because the coefficient of static friction between the concrete and the sole of my shoe value is lowered due to the water acting as a lubricant. Recalling the equation for static friction, the maximum static friction is now less and can be easily overcome. Since the normal force is also directly proportional to the static friction, less weight is needed to be acted on the ground. Thus, when running on the wet court, I chose not to run full speed as I may exert too much force and slip. Vice versa, on the dry court, I'm able to exert more force as the maximum static friction is now a higher value and I do not have to worry about slipping. The same reasoning can be applied when I'm jumping. When the court was wet, I had a hard time gaining traction, thus I had to settle for using lesser power so I wouldn't die. When the court was dry, however, only then could I apply maximum weight to the concrete and jump higher. Moving on to the passing element of the game, I decided to show how friction is necessary in this aspect. In the first video, my friend and I were trying to mimic hard passes that would occur in the game and how not having friction is a disadvantage. As you can see, the ball slipped out of my hands, but fortunately I was able to fumble it back. This can be linked back to the concept of low maximum frictional static force due to the addition of water and how water acts as a lubricant, which lowers overall friction between two surfaces. In this instance, my hands and the ball. In a real game scenario, this could happen with sweat, and if I had not fumbled for the ball, I would have turned over the ball to the opponent. However, let's say there's no water and everything is dry now. High friction can also be used to our advantage offensively. Here, you can see me incorporating some spin to the ball in a bounce pass to my friend slash teammate. In the situation where he is being defended, I can apply the spin so that the ball is passed to him safely in a spot where the defender is out of reach. This simple key concept can be explained from this graphic that I've drawn. Since we know friction always opposes motion, static frictional force, which is now a higher value due to the higher frictional coefficient, is larger than the force applied from the motion of the ball. The resultant force of the ball is thus to the right, changing its direction after it touches the ground. Friction can also help with finishing around the rim as well as shooting the ball in the hoop. For this demonstration, I used two balls made of different materials, one made of worn out compound leather and another made of rubber with a rough bumpy surface. Do note that both of the balls and the backboard are wet due to the rain. I then spun both on the backboard with the intention of spinning it into the hoop. I hypothesized that the rubber ball would be able to grip the glass backboard better than the leather ball despite the wet surface as it had a rougher surface, which would increase the frictional force. However, upon testing, I quickly found out that both gave me the same results. The leather ball, which was smooth, ended up not gripping the backboard at all, while the rougher rubber ball ended up gripping the backboard only once. This is once again another example of water lowering the max frictional coefficient of the ball and the board. However, this time the max force is so low that it converts to kinetic frictional force almost instantaneously, and there is no friction between the board and the balls. After waiting a while for the water to dry off, finishing using some spin became much more noticeable and easier. There are two ways you can finish while spinning the ball. The first way is finishing on the right side and the other on the left. With the help of a visual graphic I drew, to finish on the right side, a spin to which the ball rotates clockwise from the top view has to be applied. Since the max static frictional force is higher in dry conditions, and recalling the way friction opposes motion, with a clockwise force acting right on the backboard, the resultant force will be towards the left to the hoop, and hence the ball moves to the left. Vice versa for finishing on the left side, where applying an anti-clockwise rotational spin will allow the ball to move to the right and into the hoop upon physical contact with the backboard. Lastly, friction can also help with the way the ball bounces around the rim when shooting to increase our make percentage. This is pretty much the same concept of high maximum static frictional force not being exceeded by an applied force, or in this case the rotating top of the ball. As you can see in this slow-mo shot example, the ball bounced a total of 3 times, all of which helped it get into the hoop. For an easier explanation, I have drawn graphics for each bounce. For bounce 1, the frictional force on the rim actually changed the direction of the ball spin and started spinning the other way on bounce 2. The frictional force at bounce 1 also reduced its forward motion and instead bounced in a more upward trajectory. At bounce 2, the ball spins even higher upwards from the backboard due to the direction of friction as shown. At bounce 3, the direction of the spin and the distance the ball had bounced was in favor. The ball ended up just barely landing on the farthest part of the rim, and the frictional force between the ball and the rim also ended up in the direction of the hole instead of out of the hole of the hoop. So there you have it. I hope you managed to learn alongside me about the importance of friction in the game of basketball and how friction works. This has been Javaz, and thank you for watching.